You enough headaches. Thank you so much. uh, Hello, everybody. Welcome back. Thank you so much for being here. My name is Monica Munoz-Torres, and I have the pleasure of telling you a story in 15 minutes that has taken us about 3 years to build. So it'll go very fast. There's a QR code so you can access that resource as well. And I'll be here so I can answer your questions later. This is the work of many people. I will list all of these authors at the end. Um, so I'll tell you a little bit about the background on the Bridge to Artificial Intelligence project, which is I suppose, the project behind all of this effort trying to get best practices. I'll tell you how we worked on getting to these recommendations. I'll start by sharing a little bit about what we believe to be fundamental requirements for getting data ready for AI and ML. And then I'll tell you a little bit about what those criteria and practices are. And last but not least, give you an idea on how we in the Bridge2AI project self-evaluated to figure out how close we were to reaching AI readiness. If you haven't heard about Bridge to Artificial Intelligence or Bridge2AI, it's a project of the United States National Institutes of Health. About $130 million were dedicated to a process to try to generate data in an innovative way. We have three pillars that are the foundation of what we do: data, ethics, and people, because we want to generate new data sets with best practices that help us propel modern artificial intelligence and machine learning models towards scientific pioneering. This we'll do by getting distinctive, fair, and AI-ready data. We're also trying to advance a new culture on how we take into account ethical considerations for how the data are generated. And we do this through accurate, reliable, and ethically sourced data sets. Last but not least, our intention is to get a modernized workforce that is skilled in this new method of scientific data creation. There are 4 data generation projects. 3 of them are clinical, and 1 generates genomics data. You'll feel very familiar with what they're doing. Rapidly or very briefly, the first one is called the Precision Public Health Data Generation Project. It's focused on a database of approximately 10,000 distinctive bioacoustic waveforms, and we're trying to establish biomarkers, voice biomarkers in mental health, in respiratory diseases, neurological diseases, and other areas. There's another project called Salutogenesis. What makes us healthy, and how do we get back to health after we've been ill? This is an atlas of approximately 4,000 individuals around the pathogenesis and salutogenesis to expand the applications of artificial intelligence in clinical care. And this focuses on type 2 diabetes. Our third project is called the Clinical Care Grand Challenge, and this is about generating data from approximately 100,000 patients across 14 intensive care units and hospitals across the United States and Canada. And we're trying to do this to learn how to improve the recovery from acute illness. Last but not least, our functional genomics project is focused on a library of large-scale maps of cellular structure and function and disease context using cell lines. We're trying to do perturbation of about 200 genes and proteins for coordinated experiments. As you can see on the far right, we have these very diverse data types, EHR records, mobile health, waveform, and others on the more clinical projects. And then protein perturbation through immunofluorescence imaging, mass spectrometry, and transcriptional profiling. So what do we have to do? It is paramount for us to characterize our data sets to get to that point when they are ready for AI ML. We have heard this all morning, and our colleague from the Fairdown Seek was actually setting the stage perfectly for me, because she actually was able to describe a lot of the things that we need on how we have reached this critical mass of data. And all of this increased use of artificial intelligence in machine learning in biomedical research truly harbors this promise to enable deeper insights, but it's also creating some increased demands on both ethical and explainable artificial intelligence. This XAI, explainable artificial intelligence, has to just extend across the spectrum. So this includes the preparation, the data acquisition, the post-acquisition transformation, and model training. All of this must be transparent. And data sets, as much as we would love for them to be ground truths, are still products of human-developed acquisition, preparation, processing, governance practices, and all of these have potentials for bias and error, and it's important for us to consider the ethical and social implications that affect these applications. So what we have to do is to characterize provenance, semantics, statistics, data quality, standards, conformance, ethical governance, sustainability, fairness, and computability. I have about 9 minutes to tell you how we're doing that. So how do we really try to apply all of these emerging artificial intelligence technologies to biomedical data? You know this, you work in this field. This is a question that evolves all the time. And I'll tell you about a story from 2019, which is, in artificial intelligence, like 3 decades ago. But the truth is that data sets alone are not these ground truths. We need to have information about use cases. So we have data that are fit for purpose. And we also need to have metadata to inform it. So in this few slides, I'll tell you about a set of criteria that help us to reach AI readiness in an evaluation method for how to do it. Again, a million years ago in 2019, the NIH issued a report from the advisory committee to the director that talked about how do we reach AI readiness. And it says that it needed all of these aspects that I have listed here. I mentioned some of those earlier. What we've done is to integrate and reorganize and clarify these very foundational ideas of sample size, multimodality, perturbations, all of this, to try to generate a set of practices that we can actually work with in order to make our data ready. I know it sounds a little bit of a Captain Obvious thing to say, but over here on the right, I've listed all the definitions that we set on our document in order to be able to set some ground, some baseline for everybody to understand what we mean by AI ready, what we mean by explainable efficient intelligence, in machine learning and other concepts. It is not enough for the data to be usable for prediction. Data, in order to reach AI readiness, requires reliability, quality, ethical constraints, and explainability. And to issue the criteria that I'll share in a second, we've integrated the requirements that are based on the data's properties, the practices that we use to achieve those properties, and some examples about those practices. This is a group effort, and so I'll take you into the journey of what we've called this AI readiness criteria wheel. It starts as the morning started and as many of you have already experienced, right? We have to have these digital objects need to be fair in order to have a good ground. We need to know where the data comes from, what are the origins and the transformational history of all these data, digital objects, and all of this needs to be richly documented. And we believe that we have to have very good characterization in terms of semantics, statistics, standardization properties of the digital objects, and well-described data sets and software, which includes assessing quality and bias. This one on pre-model explainability has actually evolved from when we actually issued the preprint, because we've now understood in the last few months since we shared it that the part of the pre-model explainability where we support explainability of the predictions and classifications, fit for purpose and data integrity, it's actually not in one specific place. It should be around the entire wheel. This is where we'll have data documentation templates, such as data sheets for data sets, and other ways of actually understanding and better explaining the data from the beginning throughout its life cycle. We also need to have information about the ethical data acquisition and management and the dissemination, and document and maintain this information. And we truly believe that the ethics of how the data are generated, maintained, and shared are critical to its AI readiness. This is a word we have been using all morning, all afternoon, and that I'm sure lingers very heavily in all of our minds: sustainability. In this context, we believe that all of these digital objects and their metadata have to be stored in fair and long-term stable archives. What does stable mean? Mean in this moment? It's a bit challenging, ambiguous, uncertain, and so we have to figure out how to work in order to reach those places that try to be stable archives. I believe NIH, I don't know how many NIH people are here. I don't know if there are any, but I believe NIH is now saying something along the lines of, do you have money for 5 years? That sounds like stability, like something stable. Last but not least, computability. The data, these digital objects have to be standardized and computationally accessible, portable, and contextualized. These 7 components, we truly believe, make the wheel for AI readiness. And we truly believe that by at least adhering and evaluating your data to get to this point, you will be able to have data that are ready. And so here's how this works. We actually created a rubric with a table that you can utilize in order to self-evaluate and tell whether or not your data has actually achieved AI readiness. So I'm just going to run you through one of the examples. When we're talking about achieving, good practices in provenance, we're talking about transparency, where we identify sources of data back to reasonable ground truth. Traceable, because we identify important data transformation steps with links to software at an appropriate level of detail, ideally using machine readable representation. We also make sure that the data are interpretable. So we make software for key data transformation and analysis steps and make all of this available. And we make sure that key actors are identified. And this can be done through ORCIDs or RORs or several other identifiers. So this is just one of the 7 fields. And this is how we've described so that you can use these practices to self-evaluate. In the Bridge2AI project, we actually invited all of our grant challenges to self-evaluate and measure whether or not we were getting to this AI readiness. This figure is not an attempt to compare one against each other, but rather giving them the opportunity to further develop and improve and discuss and implement best practices to get to that AI readiness. And so basically each criterion from the table that I showed you is now an axis in this radar plot. I'll get closer to this. And so, for instance, for this one grant challenge, their characterization evaluation, it's a little bit lower. They've met requirements for semantics and standards, but they have not met requirements to explain much on the Department of Statistics and metrics about their data. We don't have information about their potential sources of bias, and we don't have a lot of information about data quality. They told us they haven't reached that yet. That's why their score for the characterization is not as high. On the other hand, this other group has actually met all of those requirements, and so for characterization, they've met that goal of characterization all the way to the top. So if you take nothing more out of the last 10 minutes, I'll share that we truly believe that preparing data to be ready for artificial intelligence and machine learning analysis requires that we understand the data itself, that we understand the predictive task for which it will be used, right? Use cases, that we have scientific domain of the data that we're trying to generate and organize, statistical methods, AI technologies, biomedical data standards, that we have appropriate ethical practices, and of course, that we consider sustainability within the biomedical data ecosystem. Our combined efforts have yielded defined practices and criteria that I've shared with you, a formal evaluation approach against this criteria, and a detailed evaluation of our grant challenges in the Bridge2AI project. I'm going to be here the rest of the week, and you can also find us online. You can also come on Slack and just, you are welcome to provide us your feedback about these criteria that I've shared. Timothy Clark is the lead author. Harry Caulfield is here in the room. I've seen a few. Nomi Harris is here. There's Marcin Hochimiak and others. Thank you so much for your contributions. And they are all authors in this work. This work is supported by NIH awards to 7 different groups across the United States through NHGRI and the Common Fund Data Ecosystem. And again, I'm Monica Munoz-Torres, University of Colorado, Anschutz Medical Campus. Thank you.
Questions? We have plenty of time, at least 5 minutes for questions.
Thank you for that. I actually have a real question.
Good.
That no one paid me to ask. Okay. I like the sort of the radar diagram that you had of all of the AI readiness levels. And it seemed like that was evaluated by different groups and then doing the self-assessment. And it just occurred to me to ask the question about the actual data types. what is your opinion? Like, are there actually data types that we're concerned with in the health space that are inherently not going to be good at some of these characteristics? And so we need to think not just about the organizations and their capabilities or their interests, but actually on specific data types or specific places where we might be acquiring data, where there's inherent challenges that we could use this framework or adapt it to expose, that this is harder to get into that space. It's going to be less reliable. And so we need to work harder. I'll stop there.
You bet. In this particular radar plot, all the way to the upper right, you can see that this group has not done very good job on computability. The truth is there are data types for which standards do not exist to even collect them, disseminate them. It sounds bizarre, but when you think about it, there's a group that is collecting recordings of voices from the patients in order to look into the biomarkers, into the speech patterns. You can record on an iPhone and you can record on a studio or an Android, and there may be effects to how those data are being recorded. After that, how do you standardize the way in which you process and transform all of this information? And so for that, they had to generate a standard on how to capture that information. For the patients that are in the intensive care unit, you have a patient who has not consented for data to be collected, right? They're unconscious, and you have no way of ethically waking them up to ask for this. Sorry, that's probably horrible to say. And so you have family, or what they have consented when the family came in. And so there are some data types that we have already seen this gap. By the way, this was the status in December of 2024. So this is about 7 months ago. This has evolved, and we'll be publishing an updated version of this. We've been working with the groups on making sure that they are able to meet those challenges and try to meet those criteria. Thank you, Jason.
Hi, thank you very much. Very nice work. My name is Robert Höndorf
Hi.
from Kausen. So I have one question. Did you actually evaluate existing successful AI models, whether
Thank
they
you.
have employed these criteria? Because I can think of many reasons why, for example, ignoring ethics makes my model more successful, a lot more successful.
La 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 la.
No, but I'm
Yes,
serious.
yeah. No, you're absolutely right. Thank you for sharing that. Yes, so these groups have actually, not all of them have done this process of generating a model, testing and evaluating. But in order for us to say, oh, the data are ready for AI, they have to have actually run models and be able to test this data against them. Our idea for ethics specifically, it involves governance, and it involves data use agreements, and it involves IRBs, and it involves consent and several other layers. And so this is not considering ethics, just from the LC components, but all of the other components. I'm sure it would make it easier and achieve it faster, but we are really trying hard to ethically source the data and to represent and to also tell the research community that it is worth the trouble. Cheers. Larry.
Moni.
Hi.
Hi. I don't want you to take this the wrong way.
I don't take it personally.
We're 5 years in from the report.
Yes,
3
6.
years. Right.
Almost
6 years.
6, yeah.
6 years. The grants all went out in 21, as I recall, or maybe the money started in early 22. We spent $130 million. Have we gotten any applications out? Is this overhead worth it?
Thank you. That is a fantastic question. Yes. And you know what? I have to say, we can do a much better job about dissemination of applications. What we have learned so far is there are very good and potential applications for the early detection of Parkinson's using biomarkers. I know that, this is not published. This is kind of like this is where the data are showing us the indication. There has also been a lot of realization of what we can do with data that is being taken from patients with diabetes type 2, specifically retinal scans, because there were, when the work started, this group was like, we're going to take retinal scans from everybody. It's going to go out and everybody's going to be able to use it. And the ethics group went, well, hang on a second. Those are identifiable data. Your patients, you're exposing all of this. And so we, together with the ethics groups and the data generation project, they were able to come to a much better formalized way of protecting privacy when taking those data. And I think that is an advance. I don't think we're the group that was generating the data were not aware of the risks that they were putting their patients under. Some people consider voice to be unidentifiable markers. It's still a debate. And so we're trying to share that. So there have been some definitely insights that have been generated from the Grand Challenges work. And from our part, we've actually been able to create a registry of information regarding the data types that they're utilizing, the standards that they're using in order to assess those data types. We've created a registry of use cases, and through a way to explore all of this, people who are not part of the consortium can come and ask questions about, well, I have a question about imaging, specifically neuroimaging. If I have this type of imaging and I'm trying to answer this question for my area of interest, do I have an answer? Like, can I learn something from what Bridge2AI has done? And we have the ability to answer those questions through our Standards Explorer. He's not happy, but I am.
I'm not unhappy. I just think that over the last 3 or 4 years, we've seen an explosion of AI applications in biology and medicine. Okay, a tremendous amount of really important work has happened. And I think the $130 million, and I thought this at the beginning when I bridged AI, can't we actually do some AI? So I was pretty pissed off about this project. It just seems to me that we haven't, and this is not your fault.
No.
But I do think that we could look at this project and wonder if we could have done something better with all that money in terms of the results we got, if the goal was to generate AI models in biology and medicine.
Ooh, there's no surprise there. Could we have done better? 100%. I think that there are many things that we could have done better. The good thing is, and I don't want to do a disservice, I truly, truly, truly believe I'm probably not speaking to all of the advantages and all of the great things that we have learned from the 4 data generation projects that have happened. I mean, we're building a map of cells, and after we've done these perturbations with these 200 genes, we're trying to get a much better comprehension of what does it look like when the cell is sick, and what does it take for the cell to go back to health. That was in there, and it's incredibly it's a wealth of information that a community that has been working for the last 2 decades is really excited about. So I know there's a lot more information that I am not doing complete justice to. Yes, go ahead, Chunga.
Sorry, we are.
Oh, sorry.
Yeah, but
You can find me in the back.
Exactly. Please find Moni after this session, and I think it'll be a very